Alright guys, welcome back to the YouTube channel. So I came across this question that says copper has an atomic weight of 6.35 gram per mole, FCC structure, and a density of this. So we have to look for the unit cell, which is A, lattice parameter. We have to look for R, and we have to look for D, HKL. Right? So this question is literally the same thing as this question that I solved earlier. Right? And if you look at this question, here we are giving copper, we are giving the atomic radius, but in the other one we are not giving the atomic radius. Here we are also giving the atomic weight, yada yada. So it's the same thing, but it's just kind of twisted. So if we come here, all we have to do is we have to make VC the subject of the formula, right? Therefore, making VC the subject of the formula, we have VC is equals to NA over density times Avogadro's number. So that's all. I cross multiplied here, right? Then I divided both sides by density and Avogadro's number. So after you do this, the next thing you want to do when you get your volume of your unit cell, we need to remind ourselves that volume of your unit cell is equals to A cubed, right? So we say A, since we are looking for A, is equal to root, that's cube roots of VC. So whatever answer we get here, we remind ourselves that A, that is parameter of FCC, is equal to, AFCC is equal to 2 root 2 R. So we are looking for R in this equation, right? So we go ahead and say our R is equal to A over 2 root 2. So this is how we get to find our R. Also for our interplanar spacing D111, it's going to be equal to A over root H root 1 square plus 1 square plus 1 square, because we're already given our DHKL, where here, from here, we have our H to be 1, our K is equal to 1, and our L is equal to 1. And we derive our A from this place. So this is where we find our A. This is where we'll find our A. Alright, quickly, let's take a recap. We know that density is equal to number of atoms in the unit cell. Our unit cell is FCC, which is 4. Then our atomic weight is 63.5. So we say 4 times 63.5 over our Avogadro's number, which is 6.023 times 10 raised to the power 23 times our volume of unit cell. So here we make our volume of unit cell the subject of formula. It becomes this on this side. So making it the subject of formula, we say number of atoms, which is 4 times 63.5 atomic weight over our density, in which here we are given the density already, which is 8.93 gram per centimeter cube times our Avogadro's constant. So when we get our V, when we get our volume of unit cell, we need to find our A. So we know that volume of unit cell is equals to cube of A. So we say A is equals to the cube root of volume of unit cell. So when we derive our A, we look for our radius that we are looking for. So we remind ourselves that lattice parameter A of FCC is equals to 2 root 2 times radius. So making radius subject of the formula, we get radius is equals to A over 2 root 2. Then when you get your final answer, you get to solve number 3 that says you look for the interplanar spacing, DHKL. So DHKL is equals to lattice parameter A over root of H square plus K square and plus L square. So we know our HKL is 111. So we get to input that. So we found our A here previously. So we put our A value there, then we solve. And that is that about that. If there's any complication, just drop a comment below and I'll get to respond to it. Thank you. Bye and peace out.